In this video, we'll take a look at section 8.4, which is properties of logarithmic functions. Now, our first objective is using the properties of logarithmic functions to expand or condense expressions. Let's take a look at our first property. This is called the product rule. Now, for any positive numbers m and n, and any logarithm base a, log base a of m times n, this is equal to log base a of m plus log base a of n. So when you're multiplying within the log, you could expand it out with addition. So let's take a look at an example. Express as a sum of logarithms. So we have log base 5. So we have log base 5 of 25 times 5. So since we're multiplying within the log, I could expand this out with addition. So this becomes log base 5 of 25 plus log base 5 of 5. And now we just expanded that log out. Now if you wanted to take this a little bit further, each one of these logs I could simplify. Log base 5 of 25, I'm trying to find 5 raised to what power gives me 25, which in this case would be 2, plus. And now log base 5 of 5, this was one of our properties, this is equal to 1. So I have 2 plus 1, which is equal to 3. Now for this particular example, all it was asking us for was to just expand it out. So this would have been our final answer. Okay. The last two steps I just simplified it and I added those two numbers with each other. Okay. But our final answer is log base 5 of 25 plus log base 5 of 5. Let's take a look at another example. Express as a sum of logarithms. So I have log base b of 3x. So now 3x, remember this is 3 times x. So I am multiplying within that log. So with multiplication, I could expand it with addition. So this would become log base b of 3 plus log base b of x. And then I'm done. Now for this next problem, express as a single logarithm. So I want to combine these so they are just one log. So I have log base 3 of 7 plus log base 3 of 5. Okay. Well, if I go back to my property, so I saw from left to right. Now what I'm going to do is go from right to left. So if I'm adding two logs with each other, I can combine them into one log by multiplication. So for our example, we would have log base 3 of 7 times 5, which is equal to log base 3 of 35. So now I combined those two logs into just one log. Next one. So express as a single logarithm. So I have log base a of j plus log base a of a plus log base a of m. So since I am adding all of these logs together, I can combine them all with multiplication. So this would be log base a of j times a times m. So it would be log base a of j, a, m. And now we combine them into one log. Now this leads us to our quotient rule. Now the quotient rule states for any positive numbers m and n and any logarithm base a, log base a of m divided by n is equal to log base a of m divided minus log base a of n. So when we're dividing within the log, we can expand it out with subtraction. So log base t of 6 over u, this is 6 divided by u. So since I'm dividing, I could go ahead and expand this with subtraction. So this would be log base t of 6 minus log base t of u. Next one, very similar, log base b of p over q. So since I'm dividing p by q, I can expand this out with subtraction. So this would be log base b of p minus log base b of q. Next problem. This time we're going to express it as a single logarithm, meaning combine them into just one log. So I have log base 2 of 125 minus log base 2 of 5. So since I'm subtracting here, the way to combine them together is with dividing. So this becomes log base 2 of 125 divided by 5. Now 125 divided by 5, I can simplify that. I get log base 2 of 25. Now this leads us to our power rule. The power rule states for any positive number m and any real number k and any logarithm base a, log base a of m raised to the kth power, this is equal to k times log base a of m. So essentially what we could do here is we could take our exponent and bring it down to the front of our log. So for our first example, expressed as a product, so we have log base 7 of 4 raised to the 5th power. Well, what I could do is I could take my exponent of 5 and bring it down to the front of our log. So this becomes 5 times log base 7 of 4. Next one, expressed as a product, we have log base a of the square root of 5. Now square root of 5, okay, we don't necessarily see an exponent here. But what I can do is actually rewrite the square root of 5 as log base a of 5 raised to the 1/2 power. So square root is the same as raising a number to the 1/2 power. So now I could take my 1/2 and bring it to the front of my log. This gives me 1/2 times the log, 1/2 times log base a of 5. So I had to rewrite my square root as an exponent first, and then I was able to bring that exponent down and move it to the front. Now our next objective, we're going to be using all the properties together. So we're going to be using the product rule, quotient rule, and even the power rule, all in the same problem. Now for our first example, it says express in terms of logarithms of x, y, and z. Essentially what this is saying is expand out this log. So I have log base a of x squared divided by y cubed z. Okay, well first, since I'm dividing, I can expand this out with subtraction. So I have log base a of x squared minus log base a of y cubed times z. But now this log I could expand out even further since I'm multiplying my y and z with each other. So how do I expand it out with, when I'm multiplying, I use addition. So now this is equal to, I have log base a of x squared minus, now I'm going to put this in parentheses because I'm subtracting this whole log. This becomes log base a of y to the 3rd plus log base a of z. So this log over here, I expanded it out with addition, and this is what I end up with. Well, now I have exponents, so I can use the power rule. So I use my power rule and bring all my exponents to the front of my logs. So this gives me 2 times log base a of x. I have minus 3 log base a of y plus log base a of z. And then one last thing I want to do here is just distribute out this minus sign. So this is equal to 2 log base a of x minus 3 log base a of y minus log base a of z. Now notice with our problem, everything that's in the denominator of our fraction has a minus in front of it. Everything that's in the numerator is positive. Let's take a look at another problem. Okay, now for this next example, so express in terms of logarithms of x, y, and z. So I want to expand this out. But now I have log base a of the square root of x cubed over z, y. Okay, so just like we saw previously with the square root, we could change that to an exponent. So this becomes log base a of x to the third over zy raised to the 1/2 power. Now I could use my properties for exponents, and I could raise each one of these to the 1/2 power. So I could distribute this 1/2 out to each one of these. Okay, so this becomes log base a of x raised to the, now 3 times 1/2 gives me 3/2 over z raised to the 1/2, y raised to the 1/2. Okay. Now I could continue to expand it out. So since I'm dividing, I can use my subtraction property. So this becomes log base a of x raised to the 3/2 power minus log base a of z to the 1/2, y to the 1/2. Continue to expand. This log, since I am multiplying, I could expand it with addition. So now I have log base a of x raised to the 3/2 minus, and now I have to put this in parentheses, log base a of z to the 1/2 plus log base a of y to the 1/2. Now I could use my power rule, so all of my exponents I can move to the front of my logs. So this gives me 3/2 log base a of x minus 1/2 log base a of z plus 1/2 log base a of y. And then one last step, I'm going to go ahead and distribute out this minus sign, and then it will be fully expanded out. So we have 3/2 log base a of x minus 1/2 log base a of z minus 1/2 log base a of y. All right, now let's go the other way around. So for our next example, express as a single logarithm. So I want to write all these logs as just one log. So I have 5 times log base a of x minus log base a of y plus 1/4 log base a Okay, so I have 1/4 log base a of z. Okay, I want to write these as one log. So first thing I could do is I can move all of my numbers in front of my log, all the coefficients of my logs, I can move them back as exponents. So it's using the reverse of the power rule. So this gives me log base a of x raised to the 5th power minus log base a of y plus log base a of z raised to the 1/4 power. Now, previously I mentioned whatever was positive was going to be in the numerator of the fraction, whatever was negative was going to be in the denominator. Okay, so I could work this problem out a little bit easier if I know that fact. So this is positive and this is positive, which means x to the 5th and z to the 1/4 are going to be in the numerator of my fraction. And since this is negative, that means my y is going to be in the denominator. Okay. So I have log base a of x to the 5th times z to the 1/4 divided by y. So whatever has a minus, whatever log has a minus, the expression within the log is going to be in the denominator of the fraction. Whatever has a plus, whatever is positive, whichever log is positive, the expression that we're taking the log of is going to be in the numerator of our fraction. Okay. So now we combine these 3 logs into just 1 log. And even this, you could take it a little bit further. If you want to remove that rational exponent, this would be x to the 5th times the 4th root of z over y. But either solution is fine. Let's take a look at another problem. So expressed as a single logarithm, we have log base a of 2x plus 3 times log base a of x minus 3 log base a of y. So let's begin by moving all the coefficients of our logs back to exponents. So this 3, I can move back as an exponent, and then this 3 I could also move back as an exponent. So I have log base a of 2x plus log base a of x to the 3rd power minus log base a of y to the 3rd power. Now, whichever ones are positive are going to be in the numerator of the fraction. Whatever is negative is going to be in the denominator. So I have log base a of, so I have 2x times x to the 3rd over y cubed. But now we could go a step further. So the 2x times x, this gives me 2x to the 4th, and I have over y to the 3rd. And now we combine those 3 logs into just 1 log. And now this leads us to another property. So our next objective, the logarithm of the base to a power. So when we have log base a of a raised to the k power, this is equal to k. So for our first example, log base 2 of 2 raised to the 6th power. So if I use my property, this is just equal to 6. Another way to look at this problem, log base 2 of 2 raised to the 6th. Well, I could use my power rule. So I could bring my exponent down to the front of my log. So I have 6 times log base 2 of 2. Well, log base 2 of 2, this is equal to 1. So 6 times 1 just gives me 6. But instead of going through all this work, I could use my property, and I know the answer is just 6. Next one, simplify log base e of e raised to the 12th power. Using my property, this is just equal to 12. All right, so that was it for section 8.4. If you have any questions, email me. and I'll help you out.